I guess it has a yeah. So yesterday we discussed about electricity, electric current, electric potential, and resistance, Ohm's law. I guess last class hope the students understood clearly. Yeah. Now today we can go ahead with upcoming subchapters in electricity. So welcome to Physics Cartoon Camera. Today is the second day of class 10th standard. Now you can see what is resistance. There is one of a question how that resistance will be. You can see the picture over here. Uh, Copper wire. If it is exactly the copper wire, the flow of charged particles which is flowing, and you connected the resistor. Resistor in the sense of opposition of flow of charged particles. So that flow will be opposite. It can be stops the flow. Now we can compare resistance and water flow analogy. What it is. Now look here, left hand side there are pictures. It's like a pipe, water pipe. Okay. The amount of water, let's say charge. Pressure on water, voltage. Flow rate, current. These three you remember. The first one is amount of water. Amount of water compared to electricity, there is a charge. You apply pressure to the water, which means the charge you compare with voltage. Here pressure and voltage compare. Flow rate, it's a current. Current means amperes. Now you can see the second picture. Decrease hose width. The pipe which is uniform before, now we pressed a center. What happens? It decreases area. Once decreases area, resistance will be increase. Yes or no? So once area decreases, resistance will be increase. In second diagram, which means the fourth one over here, we increase the pipe length. Once we increase the pipe length, what happens? Obviously, it can oppose the flow of charged particles more, which increases resistance. Alright. Now, again the pipe with the same length, put a pebbles in it. If you place the pebbles, it increases resistivity. At the same time, it increases resistance also. Clear? So probably you understood. Still more effective way I'll explain you over here. Resistivity depends on the first one is material medium. How it is material medium, we will discuss. It depends on the material medium. So what is resistivity exact meaning? I'll tell you. Take a wood piece. Take a copper plate. Take iron plate. And at the same size of plastic sheet also you can take it. Okay. All the four you give electric charge, which means current wire itself you can attach it. You can easily touch the wood because wood having that maximum resistance. At the same time plastic also. If plastic little wet is there, then probably we will get a shock. Yes or no? Coming to copper and iron, both also will give a shock. But copper conductivity is very more than the iron. So hope you can understand that copper conductivity is very more than iron. Sir, how we can say that copper conductivity is very more? Why not iron? Both are metals, might be confused. In our electrical houses, we are connecting the copper wire. Reason? We need conductivity. We need electricity. Of course, which is having resistivity also parallelly, we will discuss. So iron wirings we won't put it. Iron wirings have the more resistance. Heat will becomes generate more than the copper wire. Hope you understood that what is resistivity. It's a kind of resistance only. It depends on the material medium. Second point, it depends on the length of the wire. It depends on the length of the wire. I'll explain you how it is depends on the length of the wire. Take 1 meter wire and take 10 meters wire. Both the wires charged particles are flowing. Okay. So which wire having more resistance? Long wire having that more resistance. Why long wire having more resistance? Because wire also made up of an atom which contains electrons, protons and neutrons generally. So already exist a number of electrons which opposes the flow of charged particles. So how much length increases more, that much more resistance will be there. Yes or no? So we can write R is directly proportional to L. This is equation number 1. Now, resistance depends upon cross section area. Okay, cross section area. How that cross section area? Let's say a thin wire as well as one thick wire with the same length. Thin wire and thick wire, both also wires only, both also same length only, but where the resistance is very more. So as per the length of the wire, what I said you, if length is more, resistance is more. If length is more, number of electrons will be there in that wire which can oppose it. Now if thin wire and thick wire which is the same length, same material, so where that resistivity is very more? Which is in thin wire. Why? Why not thick wire? We will discuss. In thick wire, for example, the charged particles are flowing both in thin wire and thick wire. Thin wire having more resistance than the thick wire. The reason behind, charged particles won't flow inside of the wire. It will flow only upper surface of the wire. But in thin wire, most of the electrons will be flow because very thin. It can oppose the more. So once resistance is depends upon the cross section area. If cross section area decreases, resistance will be increase. Okay, cross section area decreases, resistance will be increase. So from equation 1 and 2, R is directly proportional to L by A. R is directly proportional to L by A. So R is equal to rho into L by A. Rho is specific resistivity. Okay, rho. Here the word we can call it as a rho. Rho is specific resistivity. Specific resistivity. Hope you understood. So R is equal to rho into L by A. You can do cross multiplication. RA is equal to rho into L. Hence, rho is equal to RA by L. R is the resistance, A is the cross section, L is the length. Okay, so this is rho. Specific resistivity units, what it is? Generally, resistance units ohms. Resistance units ohms. What about specific resistivity units? We will find out. Resistance units ohms. Area units meter square. By length units meters. Meter will be cancelled. So specific resistivity units ohm meter. Okay, ohm meter we can write, or ohm meter we can write. Here this is only ohms. So here one more question, MCQ, there are the chances to ask. Units, resistance and resistivity. Next, the same we have studied. If one's length increases, resistance will be increased. If one's thickness decreases, again resistance will be increased. It depends on the material medium, and again it depends on the temperature. More temperature having more resistance power. Now the same experiment I want to explain you practically. How we can say that length increases, resistance increase, where we are seeing in the nature? This question asked by one of a student in generally classroom. Sir, once length increases, how that resistance is increasing? Now, let's say in the summertime generally in the village areas, power cut is very more. Reason? Due to summer, the street wire length will be increased. Before you can see very straight conductors. Once due to temperature, the length will be increased. It's like a shape will come. Due to that, there are lightly disconnections. Why it is? Resistance is increasing. Resistance increasing, conductivity decreasing. Both resistance and conductivity are inversely proportional. Ulta. Okay. Once resistance increases, conductivity is decreasing. That's the reason power cut is very more in summer days. Now cross section area where we are observing in natural life. Once cross section area increases, resistance decreasing. Cross section area decreases, resistance increasing. How to explain this practically? Without going to classroom, without going to laboratory, generally in our house itself. Very simple. You can see that there is a street wires. Street wires are very thick. Why it is thick? If thick increases, resistance decreasing, conductivity increasing. The street wires are going kilometers far away. The conductivity needed, resistance should not be. Conductivity needed. That's the reason we are connecting the thick wires in a street wire. Coming to in-house, inside of the house, we are connecting very thin wires. As a small thin wires we are connecting. Why we are connecting very thin wires? Because thin wire having more resistance power. We don't want entire electricity what is there in the street. It has to reduce it. The wires is thin wires which is reducing automatically. Resistance increasing, conductivity decreasing. Entire the current we don't want. We need again 220 volts only. 5 amperes or 10 amperes. Hope audience, the students, this example is very clear to you to understand. Can you chart? Are you satisfied with this example? Live example? Is it clear? Why the thickness and length? It depends on the resistivity. Yes, you can chart freely. Next, I'll proceed further. The same thing we have discussed over here. R is equal to rho into L by A. Rho is equal to RL by A. You can see a component A component used to regular but changing the voltage source is called as a rheostat. The electrons are restrained by the attraction of the atoms among which they move. So low resistance, good conductor, high resistance, poor conductor. Again, high resistance, highest resistance is an insulator. You can see each and every material, what are all the resistivity. Alright. Yeah. Next, let me see what you have understood. What kind of numericals CBSE board is expecting from you? We will check. The resistance of a metal wire of length 1 meter is 26 ohms at 20 degrees centigrade. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? Using table of resistivity, predict the metal of the wire. This is the question. Yes, how to solve this? Anyone can guess how to solve this? Very important question. We will see some of the audience are responding. Yes, I'll tell you how it is. The resistance of a metal wire of length L is equal to 1 meter. Yes, rho formula. L is equal to 1 meter, but there is a small tactics over here. We need to understand. Yes, formula you identified very rightly, and there are something logics to solve the answer over here. Length 1 meter. Resistance how much? 26 ohms. Now the diameter of the wire 0.3 mm. So 0.3 mm how many meters? Because length they given in meter, so the diameter also convert into meters. How much it comes? 0.3 into 10 to the power of minus 3 meters. Okay. Then we can rewrite 3 into 10 power of minus 4 meters. That is diameter. But what we want, we will see. Resistivity. Rho we want it. What is rho formula? RA by L. Here we know that only resistance as well as the length, but we don't know A value. They given diameter. Diameter, millimeters they have given, we converted into meters because length they given in meters with the same units we have considered. But this is diameter. What we want it? Radius we want it. So radius is equal to diameter by 2, which is equal to 3 by 2 into 10 power of minus 4 meters. We can write. So 3 by 2, 0.15 into 10 power minus 4 meters. That is radius. But what we want over here? A value. A in the sense of cross section area. Cross section area of a wire, let's say this is the wire. This wire cross section in the sense of it's like a circle. Yes, area of a circle, pi r square. So pi r square we are doing. No, here the student asking a question, can we make L in centimeters? Not exactly centimeters. You can check here. There is options they given ohmmeters. The length also they given in meters, but they didn't ask anything over the question as well as the answers as in centimeters. If they ask, yes, you can do it in centimeters, but generally the resistivity units are ohm meter. Ohm meter itself. No need to consider it in centimeters. It may come in a different numbers. So we need to make it easy in meters. So pi value 3.14 into radius 0.15 into 10 power of minus 4 whole square. So this is the A value. Now A value substitute over here. So R value 26 ohms into 3.14 into 0.15 into 0.15 because that is a square. 10 to the power of minus 4 whole square, which is 10 power minus 8 by length value. How much they given? 1 meter. So after multiplication you can choose the right answer. Okay, we need to simplify. Then how much value which is coming? So that is 1.85 into 10 to the power of minus 6 it comes. Okay, minus 6 it comes. So this is the way we need to solve the answer. I guess physics numericals are students are feeling easy. As a part of my service, I want to teach physics entire the country, especially rural India. Probably my channel reaches to the students where they are looking for CBSE physics as a difficulty. I am there to help them. So every day 10 to 11 p.m. from Monday to Friday, without miss I'll join. This is for entirely dedication towards the student. I'll give a complete value how to make you to understand the much better. Upcoming classes I'll teach you practically also. I'll make some models on heating effect or whatever we are studying in electricity. I'll show you the models on live. So probably you can help to other students. You can able to share my link. Let them join who are all in rural India. So if you have any questions, please feel free to ask me. I'm there always with you all the students. Hope you understood what is my intention to take live classes. Coming to go ahead, next question. A 4 ohm resistance wire is doubled on it. Calculate new resistance of the wire. Yes, after 10th standard I'll go for class 11th. After 11th standard I'll go for class 12th. By this up to examinations of February generally by CBSE board. Before that, each and every topic on the physics I want to explain you both experimentally as well as theoretically. And yes, entire up to the January 1st I have scheduled. So every day the live classes will be there until unless there is something major default. Yes, if I not take the class, you can see my community tab and I will mention that why I am not joining. But maximum days it won't happens. I'll desert to that what I promised to my students, parents and teachers. In fact, some teachers also join who are all the freshers in physics. Most welcome all the teachers. We are there to help to our students. Fine. This question, it looks very simple, but there is a something tactic over here. Audience, anyone can answer? A 4 ohm resistance wire is doubled on it. Calculate the new resistance of the wire. Let me see what audience can say this answer. Four ohms resistance wire is doubled on it. Calculate the new resistance of the wire. Any idea? The students over here, gaming zone. There is a student which is quite interesting in responding. It's encouraging. Thank you so much, gaming zone. Can you answer this question? Right or wrong, doesn't mind. Apply your own thought. I'm there to help you. Option A 4 ohms. Option B 2 ohms. Option C square root 2 ohm. Option D 1 ohm. What you will choose? No idea. Any other option other than this ABCD? Did you got any other value? Don't worry, I'm there to help you. Generally, here the students will be tamper. For example, if they give option, any one of the option is 8 ohms. Oh, 2 ohms. You choose 2 ohms. Okay, good. Something you have tried. Whatever. There is an option called as 8 ohms. Then probably children can choose this 8 ohms. Why? Because R is directly proportional to L. Their thought is R is directly proportional to L. Let's say L is the length of the wire and 4 ohms is the resistance. Now the length of the wire is doubled. Then obviously the resistance will be double. That is the way they will thought, and they will put 4 into 2, which is 8 ohms is the resistance. So they are so happy to answer this. They'll come back if that is 8 ohms is an option. But in my question there is no 8 ohms to confuse them. So they need to do something solution. Yes, we will see what it is and how to solve this type of question, which is the most confusion question in CBSE board. You can see, as you know, that R is equal to rho into L by A. So the resistance value 4 ohms. Wire doubled, it doesn't mean that resistivity changed. Resistivity is same itself. Okay. Wire doubled, the new wire is double than the actual wire. Okay. So L dash is equal to L by 2. L is equal to 2L dash, which means doubled. So L dash is equal to L by 2. Current means area. A dash is equal to double of A. Area also will be increase. Now substitute. Again repeating. Again repeating. Just let me write it and I'll set answer to you. As you know that R is equal to rho into L by A. Resistance they have given 4 ohms, which is clear. Now the wire doubled. Wire doubled, which means the length increased and how much? Half of the area of cross section also will be get doubled. Yes or no? That logic you apply. Now R is equal to 4 ohms. Resistance they are asking about if it is doubled, but resistivity will be the same, wire will be the same. On that case, rho dash is equal to rho and L dash is equal to L by 2, which means double up the length. Yes or no? Initial length is, let's say, L dash, double up the length, that is L is equal to double of initial. Now at the same time cross section area will be 2A. Now substitute over here. R dash is equal to rho dash L dash by A dash. So rho dash nothing but rho itself. L dash L by 2 by A dash 2A. We can write 1 by 4th of rho into L by A. Yes or no? So what is rho into L by A? That is R. Okay. What is R value they have given? 4, which is 1 ohm is the right answer. Clear? 1 ohm is the right answer. So this is the way we need to solve this question. Now next upcoming resistance, series and parallel. So I'll derive over here. What is resistance in series and parallel? Let us consider three resistances. Let's say R1. This is resistor R1. Another resistor we can choose, that is R2. Another resistance we can choose, that is R3. Okay, three resistance are given. Now, what is a series? Resistor R1 having two ends, first end and second end. At the same time, resistor R2 also having two ends. Okay, again first end and second end. R3 resistor also having two ends, that is again the first end and second end. Now R1 resistor second end connected to R2 resistor first end. R2 resistor second end connected to R3 resistor first end. If you keep on connected end to end connection of a resistors. Okay, end to end connection of a resistors, we can call it as resistance in series. Now these end to end resistance you connected to battery. Okay, now while connecting battery, current I will be the same. Current I will be the same across R1, across R2 and across R3. Okay, now apply Ohm's law. Yes, very good. So apply Ohm's law. According to Ohm's law, V is equal to IR. At R1 resistor, apply Ohm's law. At R1 resistor, I is the current, V1 is the potential difference across R1, across R2, V2 is the potential difference, and across R3, V3 is the potential difference. Across R1, if you apply the Ohm's law, V1 is equal to IR1. Across R2, V2 is equal to IR2. Across R3, V3 is equal to IR3. Now let's say the potential V is equal to the combination of individual potential differences V1, V2 plus V3. So IR is equal to IR1 plus IR2 plus IR3. So take a common of I. If you take a common of I, R1 plus R2 plus R3. So I will be cancelled. Finally, resistance in series is equal to R1 plus R2 plus R3. So what do you mean this? There is a doubt. Why we connected in series? For what purpose? I'll explain in easiest way. Let's say 1 ohm and 2 ohm and 3 ohms are the three resistors we connected in series. So now the audience, can you tell me what is the total resultant resistance value? Audience, you can chart 1 ohm, 2 ohm and 3 ohm we connected in series. So what is total resultant resistance? Total resultant resistance, how much it comes? Any idea? I guess John Gaming can give the answer very easily. So that is 6 ohms. Very good. Now this 6 ohms is greater than 3 ohm. 6 ohms is greater than 2 ohms. 6 ohms is greater than 1 ohm. So what you understood? If any resistors, any number of resistors, if you connect in series, the total resultant resistance is always greater than individual resistances. So we will get it maximum resistance. Okay, we will connect it maximum resistance. Next, R1, R2, R3 resistors. We can see what it is. Now let's say the three resistances R1, and one more resistor R2 and one more resistor is R3. The three resistors we connected in, we will see how we connected. All one ends at one terminal, all the other ends at other terminal. Okay. Now all one ends at one terminal, all the other ends at other terminal. Okay. These two ends you connected to battery. Fine. What happens? Current I is flowing along through R1, I1 current, along through I2, R2 current, along through R2, I2 current, along through R3, I3 current, which is flowing. Okay. Now, here again the same current I1 and I2, again I3 currents will be comes over here. I1 plus I2 plus I3 will be again I. Clear? Now, according to Ohm's law, again V is equal to IR. V is equal to IR according to Ohm's law. Then I is equal to V by R. At R1 resistor again apply the Ohm's law. I1 V. So I1 is equal to V by R1. I2 is equal to V by R2 because potential is common, which is constant, common. I1, I2, I3 value will be different over here, which is in parallel. Now I3 value V by R3. So current I is equal to I1 plus I2 plus I3. Now substitute V by R is equal to V by R1 plus V by R2 plus V by R3. Now take a common of V. 1 by R1 plus 1 by R2 plus 1 by R3. Now V will be cancelled. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So what we have understood? For example, again I gave you 1 ohm and 2 ohm and 3 ohm resistors. We connected in parallel. So 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. Take a common of LCM is 6. So 6 plus 3 plus 2, which is 11 by 6. So R is equal to 6 by 11. Approximately we will get that 0.5 ohms. So we got that minimum value. So the total resultant resistance in parallel is always lesser than individual resistances. Hope it is clear what is series and what is parallel. Clear? Now, there is a question in CBSE. An electric lamp whose resistance is 20 ohms and a conductor of 4 ohms resistance are connected to 6 volts battery. Calculate the total resistance of the circuit. B question, the current through the circuit, and C question, the potential differences across the electric lamp. Generally electric lamp you can leave it. Potential across the conductor. Potential across the conductor. Electrical lamp is not necessary over here. Only conductor. Yes. How to solve this question? Electric lamp resistance at 20 ohms. Let's say R1 is equal to 20 ohms. Conductor wire 4 ohms are connected to 6 volts battery. Now the total resultant resistance in a circuit. How they connected? how they connected? Resistance as well as wire, almost they connected in series. So the total resultant resistance in series is R1 plus R2, which is 20 plus 4, 24 ohms. So that is a question answer. Current through the circuit. Second question. So I is equal to V by R, which is 6 volts by 24, which is 1 by 4, that is equal to 0.25 amperes. So 24 ohms, 0.25 amperes is the right answer, but option C and D are yeah, are almost nearby. Now coming to option C, the potential difference across the conductor. So V is equal to I into R. So what is I value? We got it 0.25. R value how much? Across the conductor R value 4. Yes, which is 1 volt. So 24 ohms, 0.25 and 1 volt is the right answer. So this is the way we can solve the electricity questions. Now, next question. R1 10 ohms, R2 40 ohms, R3 30 ohms, R4 20 ohms and R5 60 ohms and 12 volts battery is connected in the arrangement. Calculate total resistance in the circuit and the total current flowing in the circuit. Now you can see this kind of question. The students might be confused why these different kinds of resistors and what we can do. As simple, battery we connected to the above two resistors R1 and R2, which is parallel. Yes, and the down one R3, R4, R5 also in parallel. Yes. Now these parallel total resultant resistance is connected series with the down parallel resistance. Clear? The top parallel resistance we can do. So both in parallel, 1 by Rp is equal to 1 by R1 value 10 ohms plus 1 by R2 value 40 ohms. So how much it will comes? LCM will be 40. So 4 plus 1, which is 5 by 40. So 1 by Rp is equal to 5 by 40. Rp is equal to 40 by 5. Always ulta we have to do it here. 1 by Rp value we got it. Rp value 40 by 5, which is 8 ohms. That is top result, we got 8 ohms over here. The down all are in parallel. Again 1 by Rp is equal to 1 by 20 ohms plus 1 by R3 value 30 ohms and 20 ohms plus 60 ohms. Yes. Now the total LCM will be 60, which is 2 plus 3 plus 1, which is 6 by 60. So Rp value will be 60 by 6, which is 10. 10 ohms is the total resultant resistance, the down. And again all are connected in series. So 8 ohms and 10 ohms. The total resultant resistance again 8 ohms plus 10 ohms, which is comes as 18 ohms. So probably option B and option C, but still there is a question, the total current flowing through it. Okay. So total current I is equal to V by R. So V value how much they given? 12 volts battery. So 12 by total resultant resistance how much we got? 18. So 12 by 18 value how much it is? 3 4 ja 3 6. Again 2 by 3, which is 0.67 amperes. So 18 ohms and 0.67 amperes is the right answer. Probably the teachers who joined today, the new freshers, while we teaching that, always we have to recommend given data, required data, and formula, which is the most important. So the student no need to read a question again. Yeah, probably hope you are understanding about today the concepts of resistivity, resistors, series and parallel. So tomorrow the same time we can meet 10 to 11, and as well as CBSE questions, how they will ask and how to answer that questions also tomorrow we'll discuss. Thank you so much for attending of today the class. Thank you one and all. Bye for the day. Good night. Jai Hind.